Our world is changing a lot. We're moving very much into the world of the Internet of Things, where everything now has network connectivity. We've also seen the development of a lot of industrial control systems, and these have been around for many years. Industrial control systems run equipment, elevators, they run, for example, our power plants, chemical plants. All of these, for example, are machines that are computer controlled. Now, this is where we're getting into a new area, because many of these devices previously were standalone. They weren't really connected to greater networks. Maybe there was a network from that machine itself to a control room on the premises. But now more and more these types of systems are being enabled through then internet connectivity. Take, for example, a large company puts in an air conditioning unit, or let's call it environmental controls for their head office. The company that puts in that air conditioning unit then says, well, we need internet access for that air conditioning unit so that we can remotely monitor it. That allows the vendor to be able to see, are there any problems? Is the air conditioning unit experience any errors? And so the vendor can be alerted to a problem and in some cases respond to that even before the company realizes that that air conditioning unit might have a problem. But that internet connection now allows that air conditioning unit to be accessed by people anywhere in the world. Now that's not necessarily a huge risk. Like if somebody infects our air conditioning unit, we might not really care. What are they going to do? Change the temperature? But where that becomes a problem is that air conditioning unit is sharing a network connection with many other devices. And now, if there was a breach through that unit, that could easily spread to other parts of the organization that are also maybe on that same network. The problem we have today is that every device needs to be secured. Because of the Internet of Things, we have a lot of interconnectivity of everything from not only our email and our other applications, but now much of the equipment we're using in manufacturing and power distribution. These are all being connected together, which means that we need to provide layers of support between many of these devices so that a problem in one area can't spread then to other areas. This also brings in, of course, the area of, well, supervisory control and data acquisition systems. When we look at these types of systems, these are the ones that quite often are monitoring things such as, we can say here, the flow of water through a dam. It's a supervisory control that then is monitoring, gathering data about water flows, and would allow then a person to manage that device remotely. We need to make sure that these types of systems are secure. We do audit and security of these, but the problem is that many of these devices were developed with protocols from the 1970s. These SCADA or SCADA networks, for the most part, were built without any type of security control in them. Many of these networks and devices are very old. They've been operating independently for a number of years, and it's highly unlikely that they're going to be replaced anytime soon. They just sit there and send signals back of what's happening, and so therefore they're not going to be replaced by more secure units. And yet these are connected to the networks of today, despite those lacks of security controls. In many cases, they're easily accessible. You can get to them physically because they are, for example, located in remote areas monitoring, should we say, power distribution, or they're located on a small lock or a dam that's controlling then a water flow through a riverway. And they're not really that secure. They're easily accessible, which means somebody could tamper with them as well. And the problem really with all of this is that there's a lack of awareness of the risk associated with these. Now, the advantage we have is a lot of these were written in languages like assembler, and so there's not always a lot of hackers out there that are really good at doing damage to assembler programs. But the problem for us, of course, is that there is that potential. So what do we need to do? We need just to make sure that the organization is aware of the risks associated with these, that the organization is taking steps to make sure they are not going to be compromised because, say, for example, a breach of any type of, should we say, industrial control system or SCADA network.